Hi, I'm Jonathan Brand. I'm a mission concepts engineer at Satellite Technology, and I'm here today to talk to you about commercial partnerships for exploration and the opportunities and services for Lunar CubeSat. So we are partnering with Goonhilly Earth Station and then partnering as well with the European Space Agency to explore it. So, the Moon and other inner solar system locations remain a high priority for key players like space agencies and academia, but are also becoming more and more interesting targets for industry and startups. So, for a long time, the Moon and Mars have been on the roadmaps for big agencies and key parts of the global exploration roadmap. But other big players in the commercial world have started to really look into how we can start exploiting the Moon, particularly to start generating wealth out of that, and to allow resources from the Moon to help go towards the development of systems in space which can benefit terrestrial applications as well as exploring the rest of the solar system. So when we're getting this project, we kind of asked ourselves, okay, so there's been this huge explosion in development of CubeSat projects in low Earth orbit and slightly beyond. But why hasn't the same thing happened for further afield? So, particularly the Moon and also Mars. And it seemed like the main blocks in place there were firstly flight opportunities. Very few flight opportunities to get to the Moon. Normal missions have been there in the last few years. And also the problems with communications. So on a very resource-limited platform, this becomes increasingly a problem. There are other problems such as thermal issues and various other things as well. But so we started thinking about how can we try to remove some of these hurdles to enable the same sorts of advancements that have happened with small sats and CubeSats in LEO, and make the same thing happen elsewhere in the Earth, particularly the Moon. So what we're proposing, and that proposition, is a ride and talk service. So we will be developing the communications Pathfinder mothership spacecraft, which will deliver a collection of CubeSats and other nanosatellites and other payloads to the Moon. And we'll deliver small nanosats and CubeSats into lunar orbit, provide slots on the mothership for hosted payloads, provide data relay services back between orbital assets around the Moon and the hosted payload back to Earth. And we're also looking into the possibility of providing orbit scanning services for the orbital assets. And for all this, we're aiming for a price tag of £1 million per kilo, and with a total amount of payload from the first mission of 16 kilos. So, what do all the partners bring to the partnership? So, Satellite Technology, we've had a long history of developing small satellites, and they've been getting increasingly bigger over the years. But I think at the last count, 47 spacecraft launched into orbit. So we are trying to bring this to the space segment of this project. So we'll be providing the data relay mothership. We'll also be integrating the customer payloads into the mothership, and then be providing the services around the moon. So Goonhilly Earth Station, they'll be forming the ground segment of the project. So they'll be housing the Mission Operations Centre. They'll be using the Goonhilly 6 32-metre antenna as the main antenna for this mission, and this will be a dedicated service. So for approximately 8 hours a day, this antenna will be providing the link to the mothership. And they're also well situated to provide brilliant connectivity to the rest of the world, as the transatlantic fibre optic cables comes to the UK at Goonhilly. So customers will be able to access their missions just over an internet connection. And also this is supposed to be the first node in a commercial deep space network. So European Space Agency, who initiated this program a while ago, I think in 2005, to explore commercial partnerships for exploration, set out to not only find out interesting ideas for partnerships, but actually how we would also structure those partnerships. So they basically bring to the table whatever we feel best fits with the particular project that we're going for. So we were one of, I think, 4 or 5 projects to pursue this partnership idea, with others looking at systems on the space station and other things. So yeah, we can access facilities, expertise, technology transfer, international connections with other space agencies and business networks, and support for regulatory issues with the So, what's the mission look like? So, the initial baseline is that we'll be launching into a high GTO, and then the Lunar spacecraft will be boosting out to translunar injection orbit, and then getting captured into a highly elliptical capture orbit around the moon. There'll then be a series of orbit lowering maneuvers to get to the drop-off orbits for the various customers. These will also depend on which orbits those customers will be wanting to access, and at certain points during these phases we'll be able to drop off. So we may have some customers who want to actually get dropped off immediately on the lunar transfer rather than actually going into lunar orbit, so this will be an option. And then there'll potentially be various orbits around the moon which we can access at different altitude. Then after we've dropped off the orbital payloads, we'll then raise orbit to a highly elliptical polar orbit with the apophis in the southern hemisphere. And this will be the operation data relay orbit. So once there, we'll be providing coverage with initially UHF with proximity one protocol to the orbital assets, and then expand link back to Goonhilly, and also the possibility of some support from S-Track as well. And then the data from customers will, from and to customers will go through a mission control center and out across the internet. So here are the key kind of parts of the offering. So we'll be able to provide 60 kilos, and this could be made up of a collection of standard form factor CubeSats, also the possibility of housing bespoke designed nanosatellites. Then the mission will involve a less than 2-month transfer to the Moon. So this would be a worst case. We're aiming for much less than this if possible. Then once in the lunar orbit, we'll be providing UHF communications with another ship, and then X-band communications back to Earth. And dependent on the particular architectures of the CubeSats, the potential for up to gigabit per day. And this comes at a price tag of 1 million per kilo. So that's including the transfer and a nominal mission of 6 months where we'll be providing dedicated communication support. Okay. So we'll be able to support numerous user applications. I mean, the classic agencies, governmental missions, which we'll be able to support. And these could be CubeSats or other missions going to the Moon in the same time frame, as long as they're using the same protocols. So that's why we selected proximity 1, so that we can actually provide cross support. Then there's also universities and other institutes which potentially access the service, and other private sector startups. And yeah, we're hoping to stimulate a wide range of different sorts of research around the Moon. So the science of research in volatiles, radiation monitoring, radio science, geology, seismology, the things which we're expecting particularly universities and government agencies to be interested in, but also accessing and trying to provide an accelerated route to investigating various technology demonstrations for the commercialization of locations like the Moon, so, and beyond. So we see the Moon very much as a resource in and of itself, but also potentially a very convenient laboratory where systems can be tested for use around the rest of the solar system. So potentially from Mars, lots of testing can be done on a much more rapid cycle for the development of rovers to test autonomous navigation and sensor suites. And also the Moon provides a very good environment for testing equipment that would be used on the exploration of airless bodies. It has various useful things like relatively stable orbits in reasonably low altitudes. So sensor suites that people would want to use to explore asteroids could be tested thoroughly around the Moon for long periods of time, so that before doing the final, much more complicated missions of going to asteroids to investigate them for their potential resource or science, companies or agencies can be sure that they're taking the right set of sensors with them. And then hopefully all of these opportunities to develop these technologies will lead to high capability rovers and the ability to build a sustainable presence on the Moon for humans and habitat construction, and then lead the way towards resource prospecting. So the project as it stands, we have been receiving lots of interest from various customers, and at the moment we have intent secured for about 30% of the payload application. So these are various missions which we have signed letters of intent from. We have another 30% in capture, so we're in discussions with various teams, and we're yet to sign agreements with them. And then there's a remaining roughly 30%, which is available for anyone who's interested. And we're hoping to progress towards firm commitments and try to finalise a manifest hopefully by the end of this year. Okay, so this all forms part of our long-term vision to provide infrastructure services for the Moon and then Mars. So the Pathfinder will be the first step in building up presence around the Moon. So hopefully within a couple of years of the first mission, we'll launch a second mission which will improve coverage and give another opportunity to send a collection of small satellites. And also try to turn this into a regular occurrence, so teams working on projects can plan around funding cycles, and also expanding the ground network to get full coverage with a commercial deep space network, and gradually improving the services with improved navigation and bandwidth. So yeah, the key things that we're trying to integrate with this project are improving the capability to do science, de-risking flagship missions for big agencies, and allowing small teams to access improving economy of space by making it much easier and cheaper to get to these locations, to potentially improve the access for new startup and cooperation. So this is an opportunity that people from around the world can actually take advantage of, and we do already have teams from various countries from around the world interested in this project and signed up already. And inspiration for getting the next generation excited about space. With that, I'd like to say thank you. If anyone wants more information, they can talk to me or email us on Lunar@SSTL. Thank you.
Thank you very much. Any questions? Not like that. Yellow shirt.
So I was just wondering if you had a rough timescale in mind.
Yes, so the aim for the first mission is late 2020, 2021.
Well, what propulsion are you using for your mothership?
So we investigated a few options on this. Initially, the concept we were working with was to using electric propulsion transfer, but we quickly worked out that it wouldn't. It's a commercial mission providing these opportunities to CubeSats, and the radiation environment would not be attractive for these customers. So we went for the current baselines of bipod hydrogen system, just to ensure that we can get to the moon quickly without doing too many transfers through the belts, to ensure that we can provide a good environment for our customers.
I like the idea, but most scientists don't have a few million of their own lying around.
No.
I mean, to really get the scientific involvement, you have to in some way engage the space agencies to give grants to academics to buy space on your vehicle. How do you plan to do
that? Initially, there are plenty of teams that have been looking at lunar missions and within agencies and for agency programs, and that in and of itself will then lead the agencies to say, well, okay, we've got all of these missions that we've planned out to quite extent. We need to start funding these to be able to.
Well, I mean, for example, in the United States, I can't propose to get any money like that until NASA issues a call, and somebody has to convince them to do that. So
Yeah.
What do we do?
Yeah, it's a difficult one. For big agencies which already have huge space programs, it's often kind of counterintuitively harder to get money out of them. Where we've been seeing a lot of interest is in sort of the developing space nations, which is, classically where SSTL have done a lot of their business, where the countries who've done their first couple of CubeSats and they're now interested in doing something
More.
Yeah, something more, and they don't have the kind of big established programs in place to commit to, and they don't want to do just another like slightly more interesting CubeSat than the last one. So they're thinking, okay, this is a good opportunity, and that's kind of where we've been seeing the interest. But also with big agencies, it's if there's enough of the people. Enough of the community who want the mission done, then the agencies tend to be able to find money.
Hey, anybody else? No, in that case, thank you very much. Thank you.